All right, guys. No cheat from yesterday, or not yesterday, but it would have been Tuesday. No cheat from Tuesday. Before we get started, are there questions over the homework? Questions over the homework? Yes.
Okay.
Yep.
Pencil stash in my backpack is slightly over.
All right, guys. So this is where we left off on Tuesday. 3e to the x minus 4 is equal to 8. Now, the first so many of these that we didn't need to get the term with the variable and the exponent by itself. It is possible that they do show up. And for the most part, what we're going to be looking at, that's going to be with e. E is going to be the one that we'll need to get it by itself. So for us here, to get e by itself, what is the first thing we would need to do? Yes, we would need to add 4 to each side, which will tell us that 3e to the x is equal to 12. The next thing we would need to do is to divide by 3. All right. Questions on how we got to e to the x is equal to 4. Now, once we get the term with the variable and the exponent by itself, we're going to apply a logarithm to it. And the logarithm that we're going to apply to it, its base is going to match the base of what the exponent is attached to. So here, since it's e, we use ln. We're going to apply ln to both sides. And the reason we do this is because ln of e, the natural log of e to the x, is going to reduce to x. Because e, the natural log of e, is 1. We move the exponent out front, leaving us with x is equal to the natural log of 4. And at this point here, we would, if we want to know the approximate value, we want to estimate the value of the natural log of 4. All we would need to do is grab a calculator, say natural log of 4. And it will tell us it's 1.386294361, or if we round to 3 decimal places, 1.386. And I've thought about this the last few days, and I've determined, especially on the test, if it doesn't come out nicely, so 1.386. Most of what we've dealt with so far with natural logs, logarithms, any of those, I'm going to take this here. This here is the answer. I'm not going to make you type it in. And the reason I've determined that is because really going from here to here is not showing your understanding of how to solve logarithms and solve these equations. That's just showing how, if you can type it in a calculator.
So we don't even have to type it in.
Nope. The only time you will have to type it in is if it gives us a nice number. Like some of the ones we've had so far, like the first set, x equals 4, x equals 5, where we can calculate it out. If we're starting to get decimals, these approximations, leave it. Questions on this here? E to the 4x minus 3 equals 19. Here, E is already by itself. So we just need to apply ln to both sides. Because the right-hand side is going to be the natural log of 19. The left-hand side, the natural log of e to the 4x minus 3 becomes 4x minus 3. Because mathematically, we would move it to the front of the natural log of e. Natural log of e is 1, so it simplifies because we're just doing 4x minus 3 times 1. Now we need to get x by itself, because that's why we did the natural log, was to get the exponent, that x out of the exponent, make it easier to work with. Now we just need to get it by itself. So the first thing we can do is add 3 to both sides, telling us that 4x is equal to the natural log of 19 plus 3. And last but not least, we would divide by 4, telling us x is equal to the natural log of 19 plus 3 all over 4. And that's it. We can get the approximate answer by typing it all into the calculator. That's it. Because I think it's easier just stopping here than trying to type the whole thing in, especially on the test. That's just time wasted on typing it in. We have the answer. It's just finding it in a different form. Questions on this here? Solve log base 2 of 5x minus 17 is equal to 3. When we have logarithms, and we have logs where we have a number outside of it, we have numbers outside of the log. The way we need to solve these is to get the logs together, and we need one of them. Log on one side, numbers outside on the other. And for the most part, for us, and what we're going to do in Algebra 2, anything outside the log will not have a variable. Only place variables are going to show up as inside logs, because it's going to make things a little harder, a little more difficult. So we won't look at any that have more than one log today. We'll mainly be looking at these types. Now, I'm going to rewrite it down here. So log base 2, 5x minus 17 is equal to 3. Now this log is indeed by itself. We have one log, we have a number on the other side. And our goal is to solve for x. We want to get x by itself, yes? So just like with our exponentials, x was in the exponent, we got it out of the exponent. Here, the first thing we need to do is get the x out of the logarithm, outside of the logarithm. So if I use logarithms to get rid of exponents, to get rid of logarithms, we're going to use exponents. So for this here, if I put log base 2 of 5x minus 17 to the base of 2, so I have 2 to the log base 2 of 5x minus 17, what do you think is going to happen to this here? It's going to cancel out, leaving us with 5x minus 17. Logs and exponentials simplify each other out. They're inverses. But if I do it to one side, we've got to do it to the other. So the other side is 2 to the third. Is 2 to the third a nice number? Yeah, 2 to the third is a nice number. Because we could do it in the calculator. 2 to the third power is 8. So here we're just saying that 5x minus 17 is equal to 8. We would indeed. And we can indeed actually add them together. 17 plus 8 is 25. Divide by 5. So these here, we do need to actually calculate it all the way out, because we get a nice value. It works out. Now, if we had to put both sides to the base of e, we would do that with natural logs. It's not going to simplify out because e to a power does not give us a nice number. Now, if we want to check it, we can. And really, that would be log base 2 of 5 times 5 minus 17 is equal to 3. Inside the log, 5 times 5 is 25 minus 17. Then tell us log base 2 of 8 is equal to 3. And we could calculate that in the calculator and it would work. But my main focus on checking it for the most part is making sure that this final number inside of each of the logs is not one of two things. It's not 0 or a negative. Because the number that we end up, so here 8, cannot be a 0 or a negative. Because if it's 0 or a negative, that value of x does not work. For when we just have one log, it's not going to be an issue. Or what we look at 663, there are some values that come back that are extraneous that don't work. But for this here, what we're looking at today, for the most part, we should be fine. And really, when we check it, we're just making sure here that our value of x does not make 10x minus 9 be a negative number or 0. Now, I know that these here do look a little different than your note sheets because it's been bugging me the past few days how pixelated it looks on that screen. So I've been going back through and refixing the slides so that they look a little cleaner. I think they do look a little cleaner than they have all week. So I'm starting to clean those back up. Now, solving this here, again, we need to get the variable out of the log. So what can we do first? We can put both sides to the base of 3. So we have 3 to the log base 3 of 10x minus 9. Those are gone, telling us that we have 10x minus 9 is equal to 3 to the 4th. Again, 3 to the 4th is a nice number, yes? 3 to the 4th is 81. And I will clarify what I mean by not a nice number, irrational, non-repeating, non-terminating decimals. We're having to round to get there, is what I would clarify is not nice. So our logs, natural logs, log base, those do not give us nice numbers. E does not give us a nice number. Or if it goes more than 10, or it has more than 10 unit places, so we're talking about the trillions or higher, where we get scientific notation. Next step would be to add 9. 10x is equal to, and divide both sides by 10. X equals 9. And again, the main thing is we don't want what's inside the log to be negative. And we could do it independently. We could say 10 times 9 minus 9 would be 90 minus 9, which is 81. We're good. It's a positive number. And log base 3 of 81 is indeed 4. Because we're saying 3 to the 4th power is what? 81. Questions on this here? Log base 2 of x minus 6 is equal to 5. What would we do first? Put both sides to the base of 2. 2 log base 2 of x minus 6 is x minus 6. Those will cancel out. And the other side is 32. 2 to the 5th. We can calculate that. Next step would be 2. That's it. These, the logs, no. Because I will check and verify those. I'm not specifically going to look at the decimals. And again, I came to that not so much because we have to find that value. I'm more about because what we're really trying to do and the homework's trying to test to make sure that you know how to solve, yes? Converting it to a decimal is not solving. So I don't see why I should penalize you for that when it's not a part of the actual problem. But that's it. Questions on this here? I mean, we can quote unquote make some of these harder. I have no idea how this is going to turn out. Here, because again, we've made it harder, but it's still the same because those would cancel. Telling us x minus 3 squared is equal to 32. Should have been nice if that was 4. But then we would square root both sides, telling us x minus 3 is equal to plus or minus square root of 32, I believe is 4 square roots of 2. 16 times 2 is 32. Square root of 16 is 4. We leave the 2. We would add 3. Telling us x is equal to 3 plus or minus 4 square root of 2. We wouldn't calculate it out further because that's as far as we can go and have a nice number. I just made this one up on the spot. But is it really any harder than what we've done? No, it's just getting it there and then finding different ways to solve for x. And it works out both of these actually do work because of the square. We'll make it positive. But that's it for 662. Yeah. Mm-hmm. You're good? Yeah. 663, we're going to look at problems that have more than one logarithm that we have to work with and solving it there, but that's just applying our addition, our product property and division property to logarithms. And our 664, the last section, is inequalities. Solving these with inequalities. That's it. Yeah. We good with this here? Because 6.6 was all solving. And I broke it up into multiple sections because I wanted, 661, I wanted us to introduce solving, our one-to-one, our nice ones that solve nicely. 662, we are starting to look at ones where we can't make the bases be the same. And we start seeing where we have a log on one side and not a log on the other. So we start seeing a little different ones. And then 663, 664, it's the different categories I break them up into. So that way we can see them all in different parts and not try to do all of it all at once.